So for 1.7, we'll talk about the midpoint, the distance, and the coordinate plane. So it says for number one, the coordinates of a midpoint of a segment are going to be the average of the x-coordinates and the average of the y-coordinates at the endpoints. So in other words, if I have a line and there are 2 points on the line, and I want to find the midpoint of those 2 points, I'm going to take the average of the two x-coordinates, so that's one x-coordinate, and there's the x-coordinate of the other endpoint. I'm going to add those two together and divide by 2, and that will give me the x-coordinate of my midpoint. I do the same thing for the y. So I take the y-coordinate of one endpoint, I take the y-coordinate of the other endpoint, I add them together, divide by 2, and that gives me the y-coordinate of the midpoint, because it's just the averages of the two endpoints. So if I'm going to take a look at what that looks like in practice, I'm going to go ahead and let me scroll down a bit. And let's scroll down. Just let me move this out of the way. Okay. Sorry about this. Okay. So in this example here, it says find the midpoint of CD. So I'm going to label this. This will be x1 comma y1. Whoa. x1. Whoa. It's kind of messed up there. Let's do that again. This is going to be x1 over here, comma y1 over there. Okay. And this will be x2, and this will be comma y2. So negative 4 is x1, negative 3 is y1, 8 is x2, and 9 is y2. So I'm going to take the two x-coordinates, x and x2, and I'll add them together. So I have negative 4 plus 8 divided by 2, and comma negative 3 plus 9 divided by 2. Negative 4 plus 8 is 4, and 4 divided by 2, and then negative 3 plus 9 is 6, and 6 divided by 2, well, 4 divided by 2 is 2, and 6 divided by 2 is 3, and so my midpoint is going to be 2 comma 3. So my midpoint might be somewhere there, and this would be my midpoint, 2 comma 3. Okay, and so all we did was we took the averages of the two x-coordinates of the endpoints, and then we took the average of the two y-coordinates of the endpoints, and then we get our current midpoint. So this would be the midpoint of CD. Now you don't always have to have a picture. So like I can just, as long as I have the two endpoints, like in this next example, E and F, I can figure out what the midpoint is by using the midpoint formula. So I'll label it the same way, x1, y1, x2, y2. Okay, well, x1 plus x2 is 10 plus 2 divided by 2, comma 5 plus a negative 9 divided by 2. I'll try to do this the right way. So 10 plus 2 is 12. 12 divided by 2, comma 5 plus negative 9 is negative 4. Negative 4 over 2. Well, 12 divided by 2 is 6. And negative 4 divided by 2 is negative 2. And so that would be my midpoint. So that's all really easy when you're given two endpoints and you're just asked to find the midpoint. Not too bad. However, what if we were only given one endpoint and we had to figure out what the midpoint, what if we were given one endpoint, the midpoint, and we have to figure out what the other endpoint is? And that's what's going to happen in this next problem, number 2. It says when you know the midpoint in one endpoint of a segment, you can use the midpoint formula to find the coordinates of the other endpoint. So I'm going to go ahead and show 2 different ways to do this problem. So the first thing is, let's start out by drawing a picture. You don't need to draw a picture, but let's start out that way. So I got this line here, and this might be C, and over here might be D. And it says the midpoint, so I'll label this M right here. That's going to be negative 2 comma 1, and one endpoint C is negative 5 comma 7. Okay, and so they want to know what that is, comma what that is, x comma y. So I've got my x1 and my y1, and I need to know what my x2 and my y2 are. Well, I can just do it the same way. I'm going to use my midpoint formula. Negative 5x1 plus x2, which I don't know, I'm trying to figure that out, divided by 2 is going to equal the midpoint x value, which is right here, negative 2. So I multiply both sides by 2, and I'm going to get negative 5. The 2's cancel out over there, so I'm going to have negative 5 plus x equals negative 4. Then add 5 to both sides, 5 and add 5, and I would have x sub 2 equals 1. So I know my x coordinate here would be just 1. Sorry, it's not such a great 1. That's a 1. Okay. Now, if I do the same thing for my y's. So for my y's, I'll do that over here. I'm going to take y1, 7, plus my missing y2, which I don't know, divided by 2 equals my midpoint y-coordinate, which is 1. Well, multiply both sides by 2, those cancel out, so I'm left with 7 plus y sub 2 equals 2, subtract 7, and I get y sub 2 equals negative 5. And so I know that this here, if I can fit it in there, is negative 5. So my other endpoint is 1 comma negative 5. Now I can do this a little bit differently, and I think the second way I do it might make a little bit more sense and be a little bit easier to follow. Maybe not, but I think it's just an alternative way to do it if you kind of want to stay away from maybe a more algebraic way of doing it and you kind of want to do it. So I'm going to put this all together over here. Okay, and so I'm going to get the same answer. Remember, I'm trying to get 1 negative 5 because I know algebraically that's the correct 1 negative 5 is the correct other endpoint. So let's do it this way. You take one endpoint, so like negative 5 comma 7. You take the midpoint, negative 2 comma 1, and I'm going to be trying to find out the other x-coordinate and the other y-coordinate. Well, here's what I do. I find the distance between negative 5 and negative 2. Well, to get from negative 5 to negative 2 on a number line, so if I have a number line, I'll do it over here. Here's negative 5. To get to negative 2, I would have to go to negative 4, negative 3, and negative 2, which is a distance of 1, 2, 3. So I will have to go up 3. Now, because it takes positive 3 to get from negative 5 to negative 2, and negative 2 is the midpoint, that means it has to take another positive 3 to go to the next endpoint. So negative 2 plus 3 more, negative 1, 0, 1, which makes sense because negative 2 plus 3 is 1. And I would get my other x-coordinate of my endpoint. And I can do the same thing for my y's. So on a number line, if I'm going from 7, I'll do my number line down here. Here's 7. Here's 1. To get from 7 to 1, I have to count down. So 6, 5, 4, 3, 2, 1. So I count down 6. So I went down 6, so minus 6. And again, because it's the 1 is the midpoint, I have to continue counting another negative 6. So 0, negative 1, negative 2, negative 3, negative 4, negative 5. 1, 2, 3, 4, 5, 6. And sure enough, 1 minus 6 is negative 5. And so you can see my final answer was 1, negative 5. So you can do it the algebraic way using the midpoint formula, or you could do it this method. Either way, you get the same answer. 1, negative 5 is going to be your other endpoint. So we can see what that looks like with another example on the next page. So I prefer the second method, so I'll go ahead and do that real quickly. I'm going to take, it says the midpoint of AB has coordinates 4 and negative 9. So again, take the first endpoint. So it says endpoint A has coordinates negative 3, negative 5. And so the order matters. So you have to put the endpoint and then the midpoint. So endpoint is negative 3, negative 5. The midpoint is 4, negative 9. And I'm missing that, and I'm missing the y-coordinate. Well, to get from negative 3 to 4, I have to go up 7. So I have to go up another 7 to get to the other endpoint. So 4 plus 7 is 11. To get from negative 5 to negative 9, I have to go down 4. So to get from negative 9 to the other endpoint, I have to go down 4, which is negative 13. And so my other endpoint here, or B in this case, is 11, negative 13. And I can do the same thing for this problem. Here it's a little bit nicer because it's all written out for me, or drawn out for me in a picture. So one endpoint, negative 1 comma 7, 2 comma 4. I go up 3, so I know it's 5, down 3, so it's 1. So 5 comma 1. And a check might be, use the midpoint formula and see if you get M. See if you get your midpoint here. So let's check that out. Negative 1 plus 5, we'll take the two x-coordinates, divided by 2. That's going to be negative 1 plus 5 is 4. 4 divided by 2, which is just 2. So that's my x-coordinate. Let's use commas here. And then 7 plus 1, take this y, take that y, divide by 2. 8 divided by 2 is 4. So 2 comma 4. And sure enough, that is the midpoint. So 5 comma 1 is correct. Now, to kind of switch gears a little bit, let's say I'm not so worried about finding a midpoint. So let's review, before I talk a little bit about using the distance formula, let's talk about the Pythagorean theorem. So the Pythagorean theorem says a squared plus b squared equals c squared. What that means is, here's a right triangle, and we can only use Pythagorean theorem. Oops. We can only use the Pythagorean theorem with a right triangle. So the two legs, or the two sides that are adjacent to the right angle, so that would be A and B, we call these legs. And A and B are interchangeable. Like, I could make 9B or 12A, it doesn't matter. Or I could keep it as A is 9 and 12 is B. What is important is that C is always across from the right angle. So it's always going to be A squared plus B squared equals C squared. But again, the A and the B can be interchangeable. So in this case here, I have 9 is the A and 12 is the B. So I'm going to write 9 squared plus 12 squared equals x squared. A squared plus b squared equals c squared. Okay, well, 9 squared is 81. 12 squared is 144. That's x squared. 81 plus 144 is 225. So now I got this kind of number 2 out here. What it means is x squared. Now the way to get rid of that x squared, if I want to just get it to x, I have to somehow do the opposite operation. So we already know multiplication, division go together, addition, subtraction go together. So if I'm squaring a number, to get rid of it or to cancel it out is to take the square root, take the square root of it. But of course, if you do something to one side, you have to do it to the other. So that will cancel out the x squared. It will cancel out the square with the square root. And on the left side, it will become square root of 225, which is just 15. And so 15 is equal to x. So AC is equal to x. Okay. So let's see what 2 more examples of that. So down here, I've got the situation where I'm looking for y. So same idea. I'll make that A, I'll make that B, and that becomes C. And again, this could be B, this could be A, it doesn't matter. But this has to be C. So it's going to look like 3 squared plus 4 squared equals y squared, sorry. Well, 3 squared is 9, 4 squared is 16, y squared is y squared. 25 equals y squared. And to cancel out the square, I take the square root. And so 5 equals y. Now, over here, this should be AB, because BC is already given. So we're looking for AB. Okay. Now, again, same rules apply. Our legs are A and B. So just I'll make this B, I'll make this A, just to show you that they're interchangeable, because I've been using that this left side here is A. So I'm just showing you that they're interchangeable, and this side is C. So everything stays the same. It's A squared, so in this case, 12 squared. It's B squared plus B squared. So it's going to be W squared, because that's what B is. B is W, equals C squared, 13 squared. Well, okay, I'm going to evaluate it a little bit further. So now I have 144. Plus w squared equals 13 squared, which is 169. Okay, well, if this were just a regular equation, I would subtract 144 from both sides. Sorry, that looks like a 9, doesn't it? Okay, so I would subtract 144 from both sides. Subtract 144 from both sides. Man, for some reason, my pen keeps marking an extra line there. Okay, so that will cancel out. So I'm left with w squared equals 25. So to cancel out the square, take the square root, and w equals 5. So everything is exactly the same in letters A and B, except be really careful. It's always leg squared plus leg squared equals C squared. So just because the variable is in one of the legs, you can still do the problem, but you just need to make sure you set it up correctly. So A squared plus B squared equals C squared. Now, to find the distance or length between 2 points on the coordinate plane, we're going to use the distance formula. So here's the distance formula. D equals the square root of x2 minus x1 squared plus y2 minus y1 squared. And you do need to memorize it. So one of the ways I like to memorize it is I like to draw a sleeping owl. So I start with the square root symbol. And a sleeping owl has to have eyes. A sleeping owl has a nose. Now he needs to be sleeping, so his eyes should be closed. And of course, again, he's sleeping, so we should have Z's. And my Z's kind of look like 2's. And now I've got this thing that kind of looks like a sleeping owl. The eyes, the nose, the eyes. Okay, and then I just need to put in my x's and then my y's. So x2, x1, y2, y1. And the order doesn't matter. This could be y2, y1, x2, x1. It could be x1, x2, y1, y2, except it does need to be consistent. If you do x2, x1, this has to be y2, y1. If you do x1, x2, it has to be y1, y2. So as long as you're consistent, you're okay. But generally, the order does not matter. You could put the y's over here and the x's over here, but it needs to be consistent in that x2, x1, y2, y1, or x1, x2, y1, y2, or you could put the y's over here, the x's over there. So using that formula, let's scroll down just a bit more. We're going to solve this problem. So I'm going to just plug it in. And the best way to do this, let's see here. This is going to be x1, y1. This is going to be x2, y2. So there's my there's my x2. Okay. So x1, y1, x2, y2. Okay. So plug it into the formula. So d equals the square root of x2 minus x1. So 6 minus a minus 5. So all that's squared plus negative 3 minus 8 squared. Now, the one kind of scary thing about dealing with the distance formula is the opportunity to make mistakes with your arithmetic. So be really careful. So 6 minus a minus 5 is 11. So this is 11 squared. Plus negative 3 minus 8 is a negative 11 squared. So be really careful. If you write kind of big and neat, you'll be able to see this a lot more clearly, and you hopefully won't make as many mistakes when it comes to the arithmetic. Well, 11 squared is 121, and negative 11 squared is 121, so that equals the square root of 242. Now, if the problem says I want it in simplified radical form, I have to simplify that radical. So I take 242, and I'm going to take the factors, which are 121 and 2. Then I'm going to factor out 121 into 11 and 11. And I underline the bottoms of my branches. So anytime you see doubles and you're simplifying a square root, you're going to circle it, and that number goes on the outside. Anything that's left over gets multiplied underneath. So my final answer is square root of 242, or a better answer is 11 root 2. That's the simplified radical. Okay? And of course, you could go ahead if you wanted to, just round it to a decimal, depending on what the question were to ask. So if I were to round this to 2 decimal places, I could put it at 15.56. So this is approximately 15.56. So all of these are the same thing about. Well, square root of 242 and 11 root 2 are the same thing, but 11 root 2 is probably the exact answer in its most simple form. And on the test or the quiz or whatever assessment, it'll say what form they want. If they say simplest radical form, you would go with 11 root 2. If they said round to 2 decimal places, you would say 15.56. So let's do the same thing here. So in this example, I've got, let me go ahead. Distance is going to equal, I'm going to label it, this is x1, y1, x2, y2. Okay, so it's going to be 4 minus a minus 7, 4 minus a minus 7 squared, plus negative 3 minus 5 squared. Okay, well, let's go ahead and do this one real quickly. So that's going to be 4 minus minus makes plus. So that's 11 squared. We've done that in the previous one. And then over here, negative 3 plus or minus 5 is negative 8. Negative 8 squared. Not too bad. 121, we just did that. 8 squared is 60. Negative 8 squared is 64. 121 plus 64, I think, is square root of 185. So I'm going to have to simplify this. I think I can. So I'm going to take my 185. Well, it ends in a 5, so I know I can divide it by 5 and get some factors, which would be 37. And so 37 and 5, well, both of those are prime numbers, so square root of 185 is all I can do. So you cannot factor square root of 185 any further than it already is. So that would be 13.6. And if I round to 2 decimal places, 0.60 like that. Okay? So for that one, you can just leave as is. Square root of 185 is the exact answer. Now let's keep going on down here to the next one. So a little bit more practice with the distance formula. So if we're going to decide whether or not AB and BC are congruent, in other words, are their measures the same? So let's first find the distance of AB, and then we'll find the distance of BC. Okay, well, so AB is going to use 10 and 2 and 7 and 3. So I'm going to go ahead, make my distance formula. So x2 minus x1, so 7 minus 10 squared, plus negative 3 minus 2 squared. This is for AB. I'll write that over here so I don't forget. Okay, so this is for AB, and so I've got over here, well, 7 minus 10 is negative 3. Negative 3 squared is 9. Negative 3 minus 2 is negative 5. Negative 5 squared is 25. So that equals the square root of 34. Okay, so if BC is also the distance of has a distance of square root of 34, then we can say yes, they're congruent. So let's check. So this is going to be for BC. So I'm going to take the distance of BC by first doing 4 minus 7 squared plus negative 8 minus a minus 3 squared. Oops, sorry about that. Well, 4 minus 7 is negative 3. Negative 3 squared is 9. Negative 8 minus a minus 3 is negative 5. Negative 5 squared is 25. And sure enough, it looks like the square root of 34 is the distance of BC. So because the distance of AB is square root of 34, and because the distance of BC is square root of 34, we can say that AB and BC are congruent. So we'll say yes. AB, segment AB, is congruent to segment BC. Okay? And then the last thing, we're going to put it all together here. We're going to find the distance, and we're going to find the midpoint. So when it says find KL, all they wanted us to do, find KL right here, they just want us to find the distance. So I'm going to go ahead and say KL, here's KL, that's going to equal the distance of, so square root, it's going to be negative 4 minus a minus 2 squared plus negative 3 minus 9 squared. So be really careful. Look at all these negatives and these minuses going on here. So a lot of opportunity to make mistakes. So be super careful with what you do. Okay, if you just kind of go piece by piece and be really neat and careful, it's not so bad. So this is negative 4 plus 2, because we have a minus and a minus, plus. So negative 4 plus 2, which is negative 2. Negative 2 squared is 4. If you have trouble with this part right here, spend some time kind of reviewing adding and subtracting integers. It's a skill that even after algebra you're going to need a lot. And so, unfortunately, it can yield wrong answers if you are not so strong in it. So you really want to make sure you really understand how to add and subtract integers. So over here I have negative 3 minus 9, which is negative 12. Negative 12 squared is 144. Did it again. So this equals the square root of 148. Okay? So the distance for that is square root of 148. I'll simplify that radical real quickly. So 148 is 74 and 2. That's 37 and 2. Bottom, bottom, and bottom of the branches. And I have a double of 2's. So a 2 goes on the outside, and a 37 goes underneath. So I'll say that equals 2 root 37. That's the best answer in the simplest radical form. And then for the midpoint, so I'm just going to take -2, take the average of your two x values, so -2 plus a -4 divided by 2. Again, it made that straight mark. So -2 plus a -4 is -6. That is a -6. And so my x-coordinate is going to be -3, whereas my y-coordinate is going to be 9 plus a -3 divided by 2, which is just 6 divided by 2, which is just 3. So that would be my midpoint. So this is your distance right here. And this is your midpoint over there. And that's it for Unit 1. So that was the midpoint and the distance formula, and that concludes Unit 1.